Alright, this is day 60 with AP Calculus with Sparks, and we're going to talk about slope fields. So in the previous lesson, we were talking about solutions to differential equations with given parameters. Now we're going to talk about slope fields, which are basically pictorial representations of all the possible solutions, and not the specific solutions that we found in the previous lesson. Alright, so we already know there's an infinite number of solutions to differential equation dy dx equals x plus 3. Why don't you go ahead and solve this? Pause this now, show your work, solve this for the general solution, and then I'll give you the answer in just a second, so pause this now. So, this general solution has infinite possible solutions as C can change. And then if we were given some conditions, we could substitute something in and we could actually solve for C. But what a slope field does is this is going to give us all the solutions as a picture. Alright, for the AP exam, you're expected to be able to do the following 4 things with slope fields. 1, go away. You need to be able to sketch a slope field given a differential equation. Oops, dy dx. 2, given a slope field, draw a particular solution. 3, match a slope field to a given differential equation. Gotta love matching. And the 4th one, match a slope field to a solution of a differential. Alright, so a slope field is going to look like a collection of slopes. It's not going to look like a solution or a smooth curve. So let's take a look what that would look like. So if we were to plug in the point -2, 3 and figure out what the slope is for that, we would have -2, 3. That's the point we're going to use. And for x, it's -2, so we get -2 minus 1, which is equal to -3. Notice we can do the same thing if we plug in -2, 2, which would be this point. We get the same thing, -2 minus 1 equals -3. So our slope, everywhere x is equal to -2, is going to be very steep. So if I were to draw a slope triangle right here, there is a slope of -3. So -3, try and make these parallel to that. -3, -3, -3, -3, trying to make these very steep all the way, so they all look the same. We can do the same thing at -2. sorry, negative 1. Notice we don't have to put the y value in, so x equals negative 1 gets us negative 1 minus 1, which is equal to negative 2. So the slopes at negative 1 are going to be negative 2, and so that would be a slope. If we made a slope triangle, it's going to be that steep. Notice it's not as steep as the first one. So I'm going to attempt to draw these parallel to that. Like so. And I'm going to do the same thing at x equals 0. 0 minus 1 equals negative 1. So those are going to be that slope. Something like that. Notice they're getting less steep as we go across. And we do the same thing at x equals 1. That gives us 1 minus 1, which is equal to 0. I can draw that one without any assistance. Now, this differential equation, because there's no y, we can just plug in x. If there was a y, we would need to plug in y. And then, x equals 2, we get 2 minus 1, that's 1. And that is what the slope field looks like for the differential equation x minus 1. Alright, so this one does have a y in it. So when we put in the point negative 2, 3, that's this one up here, we get negative 2 minus 3, which is negative 5. So that means this point, and then we go 1, 2, 3, 4, 5. We're aiming at this point down here. So very steep negative. Then we do the point right below it. We get negative 2, 2. Negative 2 minus 2, it's negative 4. So from this point, we go 1, 2, 3. We're aiming at the same point. So it's slightly less steep. And the next one's going to be, I bet you, negative 3. We're still aiming at that same point. And then we're going to have negative 2. And then negative 1. And then this one's going to be 0. So you can see how that's going to work. So I want you to pause this and see if you can figure out all the rest of these points, plugging in x and y values to get your slope field. Hopefully your slope field looks something like mine. So that was number 1, sketching a slope field for a given differential. We turn the page. At number 2, given a slope field, sketch a solution curve through a given point. So here's the slope field for the differential equation, x minus 1. Since this is linear, the solutions are going to be parabolas. So we can kind of see that in here. What we're going to do is first we're going to start with the point we're given, 1, negative 1, which is right here. So at this point, we have the vertex of the parabola, and obviously it's facing up because you can see all the slopes are giving us that direction. And then we just kind of sketch this one in here. It's got to do something, got to be in between. Do something like that. I'm lopsided, but that's about what that looks like. And really, that's all there is to it. You just sketch it in there so it kind of fits with those slopes as it goes through. So the next one, oops, turn the page, is to match slope fields to their solutions, or to the differential equation. So here's a bunch of slope fields, and then on the next page, you'll see a bunch of differential equations. So if we were in class, we would probably have some sort of matching activity where we could do this. But since you're not in class, what you could possibly do is cut these out and then match them up that way. That's what I would do if you were in class for this. But I'm going to go ahead and let you match those up, and I am going to give you the answers. So you can cut out each one of these slope fields and cut out each one of these equations. Or you can just have the paper side by side and match them up that way. I'm going to put the answers on this sheet. So pause this now, match them up, and then check your answers. Alright, hopefully you got what I got. Let's just take a look at a couple of these. Number 2 goes with A. So if we backtrack, A, that makes sense because the solution would be a parabola. You can see its vertex is right in here. B is e to the x, and so the solution would be e to the x plus something. So for something that looks like e to the x, and that looks like e to the x. It looks like an exponential function. Alright, so if you have questions with these, please email me and let me know. We can discuss it. Otherwise, we're going to go ahead and move on to the next one. So now we're going to do the same thing. We're going to match a slope field to a solution. However, the solutions are a little more particular. So try the same thing. I'm going to put the answers on this one, and you can match up these answers to these slope fields. So pause this now. So hopefully you got what I got. If there was some confusion about E and B, 6 and 7, sine and cosine, these ones look so much alike. And if you don't remember which one is which, another way you could do that without just looking at the graph would be to find out, well, where is this function at 0? So dy dx is equal to cosine x, and if we do that at 0, we get cosine of 0 equals 1. So we can now go over here, cosine of 0 is equal to 1, which may help make that determination for you. Alright, so let's see what else do we got. Alright. Oh, here's a good question for you to answer. So, shown below is a slope field for which of the following differential equations? Explain your reasoning for each of the choices below. So, what are you going to do to solve this one? Alright, so this looks like a question right off the AP test. So we're given the slope field, and we need to determine which of the following differential equations matches up with this. And we're going to talk about explaining our reasoning. Obviously, this is multiple choice. So when I see all of these of course are the slope at all of these points, and we know the slope has to be equal to 0 at x equals negative 1. So let's pick some points to test. So pick any point we want. Let's go with negative 1, 1. So we're going to test negative 1, 1. And see if we get out 0. Well, this is obviously not going to be 0. Let's see, this one is negative 1 times 1 minus 1, which is not 0. Negative 1 times 1 plus 1, this equals 0, so this is a possibility. Negative 1 times 1 minus 1, that's not 0. This time we just have an x, so negative 1 plus 1 to the third, this equals 0. So we have two possibles. So now we need to pick a different point where x is not equal to negative 1. So let's pick, I don't know, let's pick this one. So that looks like the slope to be 1. So we want our slope to be equal to 1 at x equals negative 2, y equals negative 1, and the slope is equal to positive 1. Well, let's see what happens. So we have our two possibles. So up here we have x equals negative 2 times negative 1, and then minus 1. So that's 2 minus 1, that's equal to positive 1. So this works. And then we'll try down here. And we have our negative 2 plus 1 cubed, negative 2 plus 1, negative 1 cubed is equal to negative 1, and we wanted it to be positive. And we didn't even have to know the value, we just need to know that these are positive slopes. And this was obviously negative. So our answer then is C. Alright, first thing you're going to do for this next problem is sketch the slope field for this differential equation. So go ahead and do that right now. Pause this and check your answer. Alright, I got something that looks about like that. Second thing we're going to do is sketch the solution curve that passes through the point 0, negative 1. And 0, negative 1 is right there. Those look like they are curving down. Something like that. I probably made that just a little bit too steep, but art is not my strong suit. Alright, so then part C is to find the particular solution to this differential equation, but we know the initial condition is f of 0 equals negative 1. So dy dx equals x over y, which means y dx equals x dx. So we take the integral of both sides. So we have 1/2 y squared equals 1/2 x squared plus c. And we know f of 0 equals negative 1, so we can plug in 0 for for x, and negative 1 for y. So we have 1/2 times negative 1 squared equals 1/2 times 0 plus c. Negative 1 squared is 1, so we get 1/2 equals c. That's a good start. So we have 1/2 y squared equals 1/2 x squared plus 1/2. And in order to get this in to y equals form, we need to solve for y. So multiply everything by 2. Running out of room. So we get y squared equals x squared plus 1. And then we take the square root, and so we get y equals plus or minus x squared plus 1. And then we have to determine if it's going to be positive or negative. And without doing anything, we can look at this right here and see from the slope field it's going down. So we're dealing with the negative. So our answer is y equals negative square root x squared plus 1. And that's all I have for today's lesson on slope fields. Catch you next time.